Hello and welcome to Applied Science BTEC. So you may be thinking about taking Applied Science BTEC as part of your sixth form studies at Harrogate Grammar School. And one of the questions you might be thinking is, what will that involve? So the Applied Science BTEC is based around 2 units. Unit 1 is the Principles and Applications of Science. It's an externally assessed examination of biology, chemistry and physics content. You've studied biology, chemistry and physics at GCSE, and what we do with the content that you've learnt there is we just build on that a little bit further. In Unit 2, we'll look at practical scientific procedures and techniques. This is an internally assessed written report demonstrating practical and technical skills and uses of appropriate equipment for specific procedures and techniques. So in lessons, we'll teach you the procedures and techniques that you'll need to know and understand and be able to carry out, and then you'll write reports about those procedures and techniques. And that is what will be assessed by your teachers. Another question you might ask is, well, why should I study a BTEC? Why BTECs allow people to be successful? Well, BTECs embody a fundamental learner-centred approach to the curriculum with a flexible unit-based structure and knowledge applied in project-based assessments. So rather than mainly focusing on exams, we look at project work. They focus on the holistic development of the practical, interpersonal and thinking skills required to be able to succeed in employment and higher education. To summarise then, BTECs will give you the skills you need in order to go out there and get jobs or move on to higher learning in the future. So I'm just going to give you a bit of a flavour of what a lesson might be like if you chose to study the Applied Science BTEC here at Harrogate Grammar School. So the aim of this small section is to understand the origins and use of emission spectra. So you may remember emission spectra from GCSE. The idea, as you can see on the screen here, is you've got this visible light spectrum here, so you can know that it goes from red through the different colours: orange, yellow, green, blue, indigo and then violet. And you may know that different elements emit different colours when they're heated, and that's what we're looking at explaining during the rest of this lesson. So if you're in school, how we introduce this to you is we get you to do a flame test using salts. So we'd ask you to follow the method that's on the left hand side of the page here. So you'd set up and light a Bunsen burner on top of a heat-proof mat, shown in diagram. You'd take a dampened splint and dip the tip into a salt as shown here. You'd place the salt end of the splint into the blue flame with the Bunsen burner, and then you note down the colour change for that salt compound. It's important to take into account the risks of doing this experiment, so you need to wear goggles, you'd tie your hair back and you'd stand behind your desks. Now this is a practical that we would carry out with you on the Applied Science BTEC course. Now you will have done similar experiments at GCSE, and you may be aware of what colour these salts will change. So we've got sodium salt, sodium chloride, potassium chloride, lithium chloride, barium chloride, copper chloride and calcium chloride. So I'm just going to give you a few moments just to think about what the colour flame will change for these different salts. Have you been able to remember any? Well, let's find out on the next slide, shall we? Okay, so hopefully you remembered some of them. We had sodium chloride would change the flame yellow and orange. Potassium chloride would change it to be purple. Lithium chloride would change it to be brick red. Barium chloride would change it to be light yellow. And copper chloride would change it to be green or turquoise. Calcium chloride would change it to be orange or red. Now if we look over here at this diagram, you can see those different colour changes for the flames. So the first one here, we've got lithium, then we've got sodium going orange, lithium went red, potassium goes purple. Down here we've got calcium, which is going the orangey red colour. And let's just see, copper is the one that goes green and turquoise. And barium is this one here, which is a light yellow. And there are other salts that would change to different colours depending on the element within them. So the question to explore now is, why do different elements produce light of different colours when they're placed into a Bunsen burner flame? So to understand that, we need to understand what happens inside the atom. So on the left hand side here you can see that we have the atom. And as we heat the atom, we give the electrons inside the atom energy. And that causes them to become excited, which means they move to a higher energy level, as shown here. So the electrons in the inner shell here it becomes excited by absorbing some heat energy, and it will move to the outer shell. You know from your GCSE chemistry knowledge, the electrons don't like to be in the outer shell. So after some time, that electron is going to move back down to a more stable energy level. As it moves down an energy level, it will emit light. Now the colour of that light is equal to the change in energy level. And as all different elements have different shells at different energy levels, that means the change in energy is different for each individual element. And the frequency of the light emitted, and hence its colour, is determined by the change in energy here. So the next few slides, we can go into that in slightly more detail. So in the previous slide, we were looking at the atom as you would do at GCSE, where you've got the nucleus in the centre and the electrons orbiting around the outside. What we will now do is we take that onto another level and look at it from the physics viewpoint in quantum physics, and look at how we have energy levels there. And how we look at the energy levels there is, rather than having them as shells, we just consider them to be levels similar to a potential well. So you can see here, this is the first electron shell, n equals 1. Then we've got n equals 2, n equals 3, and so on. And each line here represents a different energy level or electron shell within an atom. So electrons can be excited and de-excited with varying energy levels based on the particular element. So each element has different values responding to these different energy levels. This means for a particular element, varying frequencies and therefore colours of light can be emitted. So as we move from n equals 4 to n equals 3, we have a lower energy of light, so we'd have a lower frequency being emitted, something more like red light. Whereas if we went from n equals 6 to n equals 1, that's a large change in energy, so the light that's emitted will have a high frequency and therefore will be more likely violet light. In stars and chemical compounds, emission spectra can help us identify elements present and their respective proportions. So you can see here we've got the different spectra going all the way, as we did at the beginning, going from violet through to red. And then what we've got is we've got different elements here. And so we can see that lithium is going to emit these specific lines. And these emission spectra for elements are very much like fingerprints on humans, that each element has its own unique spectrum. So it will emit light of certain frequencies only, and therefore if you see those frequencies of light being emitted, you know which element is present in a certain material. So this process that we just learnt is an analytical procedure that allows you to determine the exact makeup of any compound that you've been given. You can run a flame test on that compound, you can measure the spectrum of light, and therefore work out which elements are present in that compound or material you've got. So I hope you found that interesting. I hope you feel as though you understand now why different elements give off different colours and why they have different line spectra. If you've got any more queries about the BTEC Applied Science, you can email me at rcs@harrogrammer.co.uk. I'll be more than happy to answer any questions or queries that you have about the course. Thank you for listening. Hope to see you in September. Goodbye.